Yeah, sorry about that. I need to record this to upload to YouTube. Yeah, sorry. So I was saying you can visit the GitHub, and then because I'll be installing the dependencies live along with y'all. So you can go up to the GitHub and then you can copy all of these dependencies later on as I'm installing them. Yeah, so let's just get into it. So we're gonna just create like a new directory. Yeah, and so I hope everyone has Visual Studios or something related to it installed. So you're gonna want to open up the terminal, right? And then we're gonna, we're just gonna, you can either use npm init or yarn init. So it's just to, in case you want to upload your code to GitHub, you can just keep track of it. So I'm just gonna use. So yeah, so just gonna create like a package.json, and you can install all the dependencies that are required. So yeah. Also, we want to use Hardhat. So Hardhat is like a tool that a lot of people use to develop smart contracts. So it's like a helping library. So it makes a lot of the jobs easier when you want to deploy these contracts to the actual Ethereum blockchain itself. There's also some helpful tools that's included in it. Is that so this I don't think you can use Python for it because we're going to be using JavaScript and TypeScript and Solidity for this workshop. So I don't think you can use Python. If you have like Visual Studio's code, that'll be good. Anyways, so we want to install Hardhat into our workshop. Yeah. So yeah, let's just install this. So I'll be installing along with you. So like if you have any problems that you face, you can let me know. Yeah, so currently all the dependencies for Hardhat is installed. And then how you want to start a Solidity project is you're gonna want to write npx Hardhat. So this is gonna start everything that's required to start your project itself. So what do you want to do? You want to create a JavaScript project, and then you can store it wherever location you want to. Just gonna store it in the directory I am in currently. It's just gonna, and then if you want to upload it to GitHub, you can put a git ignore just so you can put in your node modules. Yeah, so all of these are created. I'll go through what all of these means later on. So for now, it's just gonna, yeah, I think we can just leave all of this behind. So all of these things that has been created by Hardhat itself. So we're gonna go through what each of them means. Yeah. So what the thing just essentially created for you is contracts, your scripts, and your testing files. So your contracts, this is where you're going to be creating your new contracts, and it's going to be in .sol. So it's going to be, this is going to tell the compiler that this is in Solidity. So it's going to compile using that. And then your scripts are going to be to however you want to deploy your scripts. So you're going to use these scripts to deploy your contracts to the Ethereum blockchain using EVM. So you're going to be using for that. And then for test, it's just a file for you to put in any testing that you might want to do. Yeah. So let's actually get started with like our first contract. So you can essentially just delete this. Yeah, because we're not going to be using this. Also, while it's deleting, you might want to go to your hardhat.config.js, and then you also want to delete this require tool as well, because it's going to create a lot of problems if you don't. And yeah, also you might want to just change. Yeah, let's just ask you that for now. So yeah, we're going to create our new contract. So let's just name it. So you want to add .sol. So the naming of your actual file doesn't matter. Yeah, so let's just create this. Yeah, so first of all, some things that you're going to require is you're going to want to add a license identifier into your actual contract itself. So you know that everybody can use it. So how it goes is, also you want to tell the compiler that what Solidity version you want to use. So how it goes is, so what this does is that's telling the program that you want to use version that is higher than 0.8.0. So any version, any Solidity version before that, we're not going to be using it, because every time with new update, right, a lot of things changes. So we want to use the latest one that's possible. So it's going to use anything that is higher than version 8, basically. So actually, yeah. So this Solidity is kind of like your own basic JavaScript. So it's going to have classes, it's going to have function, it's also going to have variables. So how we're going to start off coding Solidity is just, so we're going to start with contract, right? And then we're just going to, so this is actually our contract name that we've given to our contract. Then we're just going to type in a simple function called hello. And then this is a public function. And it's going to return, yeah. So a lot of people who've coded before, probably familiar with like the declaration of functions, maybe other than pure and memory. But we'll just skip over these two keywords for now, because we won't need to learn about it in this workshop. And then what this function is going to do is just it wants to return. It's just going to return hello world. So whenever you call this function, you call the class, you call the contract hello world, and you call the function hello, it's just going to return hello world to you, right? And if you want to compile this contract, so what you can do is you can go to your terminal, you can type npx hardhat. All right, so this is going to call, it's going to tell npx, this is going to tell hardhat that you want to compile. Sorry. Yeah, so this is going to tell hardhat that you want to compile, and it's going to go into your contracts, and it's going to look for all the contracts that you have. So all of the files in the contracts folder will be compiled. It's just, yeah, so it says it's just compiled successfully. So this what this is, I think we can just ignore this. So yeah. I think we can just ignore this, because it doesn't really affect whatever code that we're doing. So just ignore this. And then so we created this contract called hello world, and then we will want to test the contract itself. So we want to test the contract and ensures that it returns hello world when we call the hello function. So what we're going to do is we just go to the test, and we can just yeah, we can just delete this as well. So before we do the testing, we're gonna have to install a couple of dependencies. So sorry. Yeah, so you can go to the GitHub, and then you can basically copy these 3 things. You want to copy it, and then you can go to your terminal. Right. Then you can just paste it and just press enter. And it's gonna install all the dependencies that we need. Yeah. So I'll just wait for everyone to finish, because it's gonna take maybe 1 to 2 minutes to install. So once you're done, you can let me know in the chat that you're done, so we can move on. Also, if I'm going too fast, please let me know. Because yeah, I might just go a bit too fast, and you might not be able to catch up because it's a new language and everything. Yeah, so it's just installing a lot of different packages. Yeah, I can upload the slides to the GitHub as well, or I can share it inside the open source society Telegram group. Yeah, so what it did was it installed all of these things. We're not going to be using a lot of these things today, so all of these are for higher level development. So yeah, but these are all the libraries that help to ease a lot of the pain you have when you code Solidity contracts. Yeah, so for me, I'm done. I hope everyone's done as well. If anyone is still not done, you can let me know in the chat, and then I'll wait for a while. Yeah, okay, so let's just continue. So yeah, we're gonna want to create. Oh, okay, so before that, because the test that we're gonna write is using TypeScript, so just for ease of effort, you might want to change .js to TS. If not, it's gonna create a lot of problems. Yeah, just want everyone to just change their hardhat config file from .js to TS. Okay, yeah, so also inside your hardhat config, you want to import this as well. Import this tool into your hardhat config file. So you just go over to my GitHub and just copy and paste it. Right. So yeah, we can go ahead and create the file itself. So for this, yeah, so since we're using TypeScript, just end it in .ts as well. And then we're gonna want to import some libraries as well as some functions from the hardhat itself. So we're gonna want to import hardhat ethers. Yeah, so we're importing this. And then you want to import ethers from the hardhat as well. So it's using ethers.js. And then finally, we're gonna want to import expect from Pyae. So that's what we're gonna be using to test our actual contract itself. So import. Sorry, it's expect, not expects. Yeah. Right. So I hope everyone is caught up to this point. Just save this. Yeah. So the testing is fairly simple. It shouldn't be different for Solidity as well. So any other testing that you have done, it should be the same. So we're gonna have to start with describe. This is just gonna be like the name of the testing itself. So it's just and this is the actual function of it, and this is what it should do. So it should say hi, right? Then gonna want to create an async function because we're gonna have to wait for the actual contract, the actual Hello World contract to be deployed into our local network. So what Hardhat does is it's gonna create like a local Ethereum chain in your computer, and then it's gonna deploy to that. So we're gonna have to create an async function first. Right. So so how we're gonna get the contract is we're gonna create a constant called hello world. Then we're gonna have to await. So we're using ethers from Hardhat itself to get the contract from hello world.so. So get contract factory, and then we want to give the name of the contract itself, not what we have named the file for the contract. So like you should be calling this instead of this hello world.so, even though it's the same name. And so you should be calling the contract itself and not the whatever you've named the file. So yeah, then we're gonna have to wait for it to deploy. So yeah, we're just deploying this to like a test net, test Ethereum chain, just so that we can test it out. And then afterwards, we're gonna have to ensure that it is, yeah, we're gonna have to wait for it to be deployed fully. And then we're gonna write our actual test. So we expect so what equal, let me just make sure that it is fine. So yeah, we're gonna want to test this string that we've put in. So just to ensure that it passes. Yeah, and then we're gonna want to save it. And then so like I was saying, like the Hardhat is gonna create like a local node, Ethereum node inside a computer. So how we're gonna do it is npx. So we need this command npx Hardhat node. Yeah. So once I run this, it's gonna create its own Ethereum node inside our computer. Sorry. So I have to cancel this. Yeah, so I was testing it out just now, so that's why it says it's already in use. So yeah, all of these are what your local host has created. So this is what Hardhat has created for you. So it's gonna give you 10 accounts. I'm sorry, it's gonna give you more than that. So it's gonna give you 20 accounts. And these are your account number. It is loaded up with 10,000 ETH each. But all of these, of course, aren't real money. You know, it's just in our local machine. And this is your private key, which you can import to your, let's say, MetaMask. If you want to import your local account into it. So yeah, the private key won't really matter. So what really matters is your actual account address. Yeah, so so any funds sent to these on the mainnet will be lost because they're not real. So once we have this node running, we're gonna have to open up another terminal so we can execute other commands on it. Right. So I hope everyone's caught up until this point. And yeah, so let's just get to the testing aspect of it. So how we're going to test it is npx hardhat run scripts. Yeah, sorry, it's just npx hardhat test. So yeah, so it's gonna compile it again, and then it's gonna say whether it passed or not. So this is the actual function of the test, and then see it should say hi, it passed. So let's say we change this to something else, like hello open source society, right? And then we save it. And then when we run the test again, it's gonna fail because that's not what it's returning. Right. So it's expected this, not expected, yeah. So yeah, we can see that it's actually testing the contract and it's not just giving us random pass or fail. So let's just put this back. And then now we're gonna get to the actual deployment of the contract to our local node that we've created previously. So all of these, yeah, we just created it previously. So we're gonna now deploy to one of these accounts. Yeah, we're gonna deploy like our contract to one of these accounts. So what we're gonna want to do is to go to scripts, and then under scripts there will be deploy. So this is where you put in any code that you write to deploy to the actual mainnet or anything if you want to deploy your smart contract to. So let's just get rid of all of that because we won't be needing it. So again, we're gonna want to import hardhat ethers. Then we're gonna want to import ethers from hardhat again. Yeah, so once that's done, we can move on to the actual deployment of our contracts itself. So yeah, we're gonna write two functions, and yeah, so all of these functions will be async because we're gonna have to wait for these contracts to be actually deployed onto the chain itself. So deploying on the chain is not just instantaneous because of the Ethereum Virtual Machine. You're gonna need a lot of different computers to actually accept your transaction to verify that it's true, right? Sorry, what do you mean password? Yeah, so actually this is what it's returning. If I'm reading your question correct. Yeah, let me just move on for now. So deploying is actually using JavaScript as well. So yeah. So this is the actual function that we're going to use to deploy. So like what we did on our testing, we're going to have to get the contract from hello world.sol as well. So how this is going to go is so yeah, like I mentioned previously, this is going to be your actual contract name, not your file name. So after we've done it, it's basically similar to the one that we've written in our actual testing itself. Oh, sorry. Yeah, we're gonna deploy it first, and then we're gonna ensure that it has been deployed. Yeah, let's just yeah, then afterwards we're gonna want to return the actual contract. So yeah, we're gonna want to return the actual contract to whatever that's called. So if you actually look at your artifacts and your cache, right? If you go to your artifacts and then your contracts, and then you got these two files, hello world .tbg and JSON. So you're gonna want to click into the second one, and these are whatever your compiler has compiled, and this is what it's getting every time you call get contract factory hello world. So it's going to here, and then it's getting all of your details of your contract itself. So see, you have a function called hello, so like hello, and then you also have your different outputs. So it's going to be a string, then yeah, so it's going to be your deployed bytecode. So this is what is actually deployed to the Ethereum virtual machine itself. So yeah, this is what it's actually calling whenever you do get contracts factory. So we're gonna return it, and then we're gonna create another function called say hello, and then we're just gonna console log yeah, so we're calling hello is the actual contract that we've deployed to the Ethereum blockchain itself, and then .hello is the function that we've given that's going to return us hello world. Right. So once we save it, we're going to want to deploy. We're going to run the script to deploy our contract. So how it goes is npx hardhat run scripts / deploy.js. So this is your script folder, and then we're telling hardhat basically where to go to look for our deployment script. So it's deploy.js, and then we're gonna tell what network that we wanted to use. So we're gonna want to use our localhost network that we've created over here. So if everything works, it should just deploy. Right. So sorry, give me a moment. Might be. Yes. All right. So let me just figure out what this is first. Give me like 1 minute. Sorry, just give me oh right, yeah, sorry. Obviously it's not gonna work because we called the functions. I mean, we return the functions, but we're not calling anything. So we're gonna deploy, and then we're gonna want to call say hello. Right. So okay. All right. Give me a moment. Yeah, right. So my bad. It's actually using TypeScript as well. It's not JavaScript. So yeah. So right, my naming is wrong. Yeah, sorry everyone. So it's actually TypeScript. All right, sorry. It's also, we need to wait for this to be deployed as well. And then, yeah, right. We also want to add in the contract itself, the contract hello into say hello itself. Yeah, so now everything should be fine. Yeah, so this is what we've put in our contract, and this is what we've actually put it here. So console.log. So yeah, so it's been deployed. And then if you want to take a look at your node that you've created previously, you can see all of this. So this is the actual contract that we've deployed. So this is the contract address that we've deployed. This is your transaction hacks. So this is the account that you've deployed from. So this will be your account number 0 that you're deploying from. And then, yeah, we also require gas. We'll talk about it later. So this is our first ever node that we've created. So it's going to be block 1. So this is our contract deployment. And then we're calling the contract for the hello function. So yeah, we're calling from this account, we're calling to this contract address. All right, so yeah, so like, I've given you a bit of coding. So let's actually go back to what these things mean. Yeah, so for Solidity itself, the coding is fairly simple. Your normal if loop, your normal if statements, your normal loops, and then like I've mentioned previously, your contract itself. So you want your contract and then the name, and then you can also declare your variables like any other coding language. There's also your constructors, and then your function itself. So whenever you deploy your script, deploy your contract to the Ethereum Virtual Machine itself, it's going to run all of the constructors once. So every time you deploy a new contract, it's going to run your constructor always. So all of this from to all of this, these are all hard hat. This is all produced by Hard Hat itself. So I'm not defining everything. So it's using the accounts that we've created from here. Then it's basically use this account to create the contract. And then we'll like publishing the contract to the local host node. So that's why it says from and to. So we're using, this is the address of the contract that we've created here. So like this is your contract address. right? And then we're calling from this account to the contract to get the function hello, to call function hello. So this is basically what this is doing. And this is saying that you have successfully mined a block in your Ethereum chain and you've deployed your hello world contract into that block, basically. All right. And yeah, so in Solidity, your basic integer wouldn't be like 16 or 32 bytes. It's actually 200 yeah, it's 256 bits. So it's quite a large byte, and then it's quite large, right? So you can also use it to declare any other bits that you might need. So you might not want to use all 256 bits, and like you only need like a smaller number. So you can go to uint 32 or 16 or 8. And then you can also declare other data structures in it. So you can also declare arrays. So the thing about Solidity is that if you declare an array outside of your function, right here, it's actually dynamic. So you can add however many that you want. There's no set limit. But if you declare it inside, yeah, like using this statement, it'll be a fixed array. So you can only store 10 different items into the array itself. And then we also have mapping. So this is how you would declare it. So mapping from uint type to the address array. And then this will be the name of your mapping. So how mapping is different from your typical Java or like your Python is that you can't iterate through the mapping itself. So you can use your for loops or your while loops and all of this. And then you also don't know how many different items are inside your maps itself. So if you want to use mapping, you need to know which what your key is specifically. Then you're gonna get back your address. So it's very different from your normal maps from your Java. Yeah. And then yeah, so let's move on to the second part of our code. So we're gonna build like a simple counter, your good old counter file. I mean your counter contract. So inside your contracts, you're gonna wanna create another Solidity file called counter.sol. And then like any other things, you're gonna have to put in these two lines into it. So you can just go back and copy and paste it. Doesn't really matter. And then we also want to import this hard hat console.sol. So this is just gonna help you later on. So you don't have to worry about what it does. You just have to import it, and then we'll take a look at it later. Yeah. So yeah. So this is just to declare your variable called counter, and then we're gonna create our function called count. And then it's going to be a public function, and it's going to return a uint because that's what we declared counter to be. So right, so how we're going to increase the counter is basically just counter plus plus. So it's going to increase the counter afterwards, and then we're going to want to yeah, we can console log it afterwards, and then we can return the counter itself back to whatever function that called us. So we want to save, and then you just want to type npx hard hat compile just to ensure that whatever you've written does compile. Right, so it's actually returns, not return. So yeah. Yeah, so since we have two Solidity files, it's gonna go through both of them and compile them again. So now let's actually work on deploying this counter contract that we've created. So we're gonna want to go in our scripts and just your naming convention is gonna matter here because you're gonna have to call the file later to deploy. So you just want to make sure that whatever you've typed here is going to correspond to whatever you've typed when you deploy it later. So like previously, you're going to want to copy this too. So we're going to be using the same thing in our deployed contracts script. And then, so it's basically going to be similar to whatever we've written previously. So, so we're going to want to get the counter contract from the actual contract factories itself. So and then we're going to want to make sure that it's deployed. We're going to want to deploy it. So and then afterwards, we're going to want to ensure that it's already been deployed. So we're going to wait for it. And afterwards, we're going to want to return our counter itself. And then we're going to write another function that's going to count itself. And we're just going to write another function that's going to display the counter that we've put inside our contract. So it's just right. And then we're going to want to right. So it's basically the same. We're calling the counter contract itself, and then we're calling the function count. So once we so after this, we can just deploy the contract itself. Yeah. So here this is what this is actually saying hard hat console.so. So it's gonna tell us everything about our counter itself. So this is on block number 3, and then everything that is saying. So once we actually go to our node, so this in our contract itself, we put in console log counter, and then we're gonna send the actual counter. So it's actually here. So this is your actual counter. So it actually increased by 1, and it's using so if you look here, yeah, so this is hard hat actually deploying your counter contract to the blockchain itself. So it's using block number 2, and then yeah, it's just using your gas again. And then here we're actually calling the count function, and then it's just gonna, so every transaction that you do is gonna consider as a block. So once you call count, it's gonna be another block as well, and then afterwards it's gonna throw its output here, which is counter. Then increase by 1. Right. So all of this is not actually feasible, because if you want to see, whether your counter has updated or not, you're gonna have to call a function every time. You're gonna want to call this function every time, and it's gonna add your counter and everything. So what we want to do is we want to create a function that's gonna let us view whatever the counter state is at the moment. So yeah, we're just gonna separate this function into just one function will be just to add, and then another function will be to view the counter and which number it is at currently. So let's do that. So we're gonna want to take away the return because we're not gonna return it anymore. We just we're just gonna increase the counter by 1 when we call this function. And then we're gonna create another function called getCounter. So Ethereum Solidity has this keyword called view. So what view does is that it's telling the EVM that we're not doing any state changes. We just wanna view whatever that this is, whatever. Yeah, we just want to view the variables that we have put inside here. So it's just going to return a counter, and then we'll be able to view it without calling the actual count function itself. Yeah, so we've abstracted our function. So we're gonna have to go back to our deploy contracts again, and then we're gonna have to change a few things. So here, so we just want to make sure that the counter has run the program run its function count. Yeah, so this is to actually just call the function count, and we're gonna have to wait for it to be actually called properly, because as I mentioned previously, everything requires consensus from other nodes as well. So this is actually the beauty of blockchain, right? You can't just say anything you wanted to do and then it will do it. It needs like collaboration from other nodes to ensure that whatever you're doing is correct, and that's why it's not instantaneous whenever you deploy a contract or like you call a function and then it's gonna immediately get updated. It's gonna have to go through like different it's just gonna have to go through a lot of approval from other nodes as well. So that's why we need to wait for it. And then afterwards, it's just so whatever function that we've declared previously, getCounter, we're gonna call it here, and that's gonna get us the actual counter. So we can save it, and then we can go ahead and deploy it again. So it's gonna compile again, and then so you see here, so it's just counter, and then the actual value that we've increased. So then if you actually go back to the node itself, so this is gonna redeploy the counter contract again, because we've called this function. It's gonna deploy another contract to the node itself, and then it's gonna use block number 4 because previously we used block number 3, so it's gonna increase. And then this is to call the counter. To call the function count, and it's gonna increase the counter by 1. And then here, if you notice here, it says guessed use, right? Because we're actually changing the state of whatever that's been stored inside the blockchain. So that's gonna require guess. But if we go to here, getCounter, because it's a view, we're just viewing whatever that is stored inside the blockchain. We're not actually making any changes to the variable. So that's why we're not using any guess. So that's also why using view is important, because then you won't have to pay to look at whatever what's the current state of your variables inside the blockchain. So because all of these doesn't do any state changes, so it's for free. So that's why it's important to do it. And then let's go through some of the things first. So when I declare a function, I've written like function get count public. So there's also like different scopes as well. So yeah, here view is a function set doesn't change the contract state. So we're just viewing whatever it is. So for public, everybody can call the contract, everybody can call the function that you've created. Private is only the contract itself can call the function. And then for internal is that only your contract as well as your subclasses can call the contract. And then external is you're most likely never going to use it. It's that only outside people can call it. So maybe like an interface. You want to create an interface for other people to use. Then we can just create external for it. Yeah, then so there's also this thing called this big number here. So this is because of the uint 256. So the Solidity has created its own declaration for uint 256 because it's meant for some numbers that are too big for like normal JavaScript to display. So yeah, Solidity has actually created big number for it. So if you actually change it to like uint 32, and then we can redeploy the contract, we're gonna get a different output here. Yeah, so pure is just that you can't read or write. So you can only like interact with it. So like, let's say you're creating an NFT, because you can use smart contracts to create NFT as well. And then like, you don't want people to like read the things, read your contract itself, or like write to any of the states. So like all your variables inside the contract will it'll be private, and then you also can't write to the contract. So like you can't use like counter.count. So it's not allowed when you use pure. So yeah, so once I change to uint 32, the big number disappears because it's not using uint 256 anymore, and it's just using uint 32. So it's allowed in JavaScript or TypeScript rather, and it's so that's why it just says 1 rather than big value. So then let's actually wrap up this workshop by talking about gas itself. So what gas is for every transaction that you do, you have to pay like a certain fee for it. So in Ethereum, it's called it's just called gas, and it's measured in Pyae. So it's gigaway or rather. So it's 10 to the power of 9 of like a regular way. And way is a fundamental unit of ethers. So like it's like your cents. It's like 1 cent, 2 cent, 3 cents. And then your Gwei or rather is called it's 10 to the power of 9, and your ethers is 10 to the power of 19 of your way itself. And then actually some of the functions and some of the variables that you store inside the smart contract actually varies on how much gas it will use when it's been deployed. So yeah, let's say all of these functions that you do. So let's say you want to add add something to your current variable, then it's going to cost 3 gas. Or like let's see, you want to store your address or like get the address, and it's just gonna cost different gas depending on what functions and logic that you do. So yeah, you can, all of these links, I believe I put them inside here. Oh yeah. So yeah, so it's inside there as well. And then there's also a nice Etherscan gas that you can keep track of. So like um every time I don't know if you used like you send cryptocurrency over Ethereum. So every time it's gonna cost like a little bit of money to send your transactions, right? So that's because it's changing the state of your account inside the blockchain itself. So that's why it's gonna cost you money to change the state. And then how it's tracked is how they determine how much gas they use is depending on how busy the chain is currently, because each transaction you do is there's gonna be a queue for you to enter into the blockchain, and then for you to enter the blockchain, there are many nodes that need to approve of your transaction. So like sometimes you can pay higher gas to like get ahead of the queue basically. So yeah, and like if you just pay like your normal fee, whatever that they've like your average gas fee, right? Then it's just gonna be like a very slow transaction. So like if you pay like 16 GUI, so with this one, all of this you can set it inside your contract actually of how much gas you want to pay. And then like, yeah, so it's gonna give you higher priority. So if you only pay 14, it's gonna take you 10 minutes for your transaction to go through. So the more you pay, the faster it's gonna get. Yeah. And yeah, there's also I've also added a link inside the GitHub. So it's actually by the Solidity itself. Then you can take a look around if you want to improve, if you want to learn more. It's like a whole documentation for it. Then you can just read through it. Then there's also like different updates, and yeah, so it's just good to read through the documentations to see any updates that they have done. Yeah, so 16 GUI would be 0.38 with the current Ethereum price, I believe. Yeah, because it's also depending on what actions that you do. So that's why the price will vary. Yeah, so you can also just go to my GitHub and just look at some of the previous work that I've done. So this was one of the things that I've done. So these are your scripts to deploy. So, but this was using Python, so it's quite different. So this is just some of the functions that I've written. Yeah, and then you got so this is just to deploy. For deployment, there's a lot of different languages that you can use to deploy itself. So Ethers.js is currently popular because you can use it for you can use it on your website. So you can interact on a web page itself. So that's getting very popular nowadays. So Ethers.js is what a lot of, let's say you want to go for a blockchain internship. So a lot of them requires ethers.js. So it's good to know as well. Yeah, so all of these contracts, yeah. So there's a lot of, you can also create like enums, all of these things. These are constructors. So payable is it's like telling it's saying that you need to give a certain amount to be able to call this function. So it's so this is what payable is for. And then like you can look at what your entrance fee is. So this is like a public view I mentioned previously. So this one you can set your entrance fee to whatever you want and all these things. Yeah. And so I think that's about all the content I've planned right now. Yeah. Yeah, so that's actually the end of the workshop. So if nobody has any more questions, you can leave. If you guys have questions, you can ask in the chat, and I'll be here to answer them.